So now that we know how to determine the concentration of H3O plus and OH minus from a solution that contains an acid or base, today we're going to discuss what this means in terms of this thing called pH. This is a term you've all been hearing since you were all in junior high. And we know from junior high that the pH scale determines whether or not something is an acid or a base. We know that the pH scale goes from 1 all the way up to 14. And your teachers in junior high always told you that everything that was 7 was what they called neutral, and anything that was less than 7 was an acid, and anything that was more than 7. Well, what does it mean? No one ever told you what it means. So today I'm going to tell you what this means, and we're going to need a function on your calculator to do this. The button that we're going to be using on your calculator is a button that we use to perform logarithmic functions. When we abbreviate it, it just comes out log. So to kind of set the mood, I'm going to show you a video from one of my favorite cartoon series from when I was a kid, and just sit back and enjoy because it's weird and there's no logical explanation for it. So just enjoy. Besides, it's Friday.
Hey, kid, you want a toy?
Uh-huh.
How about a bike?
No.
A video game?
No!
Well, okay. You pick a toy.
I want log! Boy, oh boy.
Yes, log. All kids love log.
What rolls downstairs, older and pairs, rolls over your neighbor's dog. What's great for a snack and fits on your back? It's log, log, log. It's log, log. It's big, it's heavy, it's wood. It's log, log. It's better than that, it's good. Everyone wants a log. You're gonna love it, log. Come on and get your log. Everyone needs a little
Log from Blammo.
So, everyone get your log from Blammo? All right, so now let's take this ball and run with it. What we know is that acids produce H plus and bases produce OH minus. How are we going to translate this into this thing called pH? This term pH, it stands for power of hydrogen, and it is simply a logarithmic table for taking the concentration of H plus, which is often an exponent, and getting it into a simple whole number, and that's all it is. And so there's a simple formula for converting pH and H3O plus back and forth. So we'll do it a couple different ways. For pH, which is a numeric equivalent for explaining the concentration of H plus in solution, it's a simple equation. We're simply going to take the negative log of the concentration of H plus. You can write it like that. You can write it like H3O plus. It means exactly the same. And so, where do we find this log button on your calculator? Right here. So make sure you have your graphing calculator with you, and the log button is this guy right here. So let's try a couple of these, and what we're going to do is we're going to convert from H plus to pH and vice versa. I'll show you how to do it from pH from H plus and pH from OH minus. All right, so let's take an example. So here's one. This is going to say, what is the pH of a 2 times 10 to the negative 4 molar solution of HL? Some of these are going to be a bit more involved than others, but this one's fairly straightforward. So we know if we have a 2 times 10 to the negative 4 molar solution of HCl, when it dissociates, we get 2 times 10 to the negative 4 molar solution of H+. To get pH, we're simply going to take that H+ and plug it right into this formula, negative log of the concentration of H+ in solution. So let's take out our calculator and plug it in. So let's take, on our calculator, we'll say negative log 2 times 10 to the negative 4. What's our pH? 3.7. And that's all you do. Let's try one going from OH minus. All right, here's one. What's the pH of a 3 times 10 to the negative 3 molar barium hydroxide solution? Obviously, we're going to dissociate this, and we get barium and 2 hydroxides, right? A little subscript. So if we have a 3 times 10 to the negative 3rd molar solution, we'll get 3 times 10 to the negative 3rd molar barium, but we don't care about that. And of course, times 2 is 6 times 10 to the negative 3rd molar hydroxide. Now, we want to get this into pH. There's a couple ways we could do this. We know that pH is equal to negative log of the concentration of H+. Well, that doesn't help us here because we have OH minus. So, a couple things that we could do. We could find H+ from OH minus by using our equation where we divide Kw by OH minus, and then we can simply plug that in here. Let's do that, and then we'll compare it to the other technique. So, Kw is 1 times 10 to the negative 14th. We're going to divide that by 6 times 10 to the negative 3rd. Good thing we have a calculator here, right here, handy. So we'll say 1, I lost my cursor, 1 times 10 to the negative 3rd, negative 14, excuse me. We're going to divide that by 6 times 10 to the negative 3rd. This is going to tell us our H+. We get 1.67 times 10 to the negative 12, and we're going to plug that right into our equation for pH. So negative log, in this case, 1.67 times 10 to the negative 12. So we're simply going to take negative log, and I'm going to be slick and just use the answer function. We get a pH of 11.78. Makes sense, it's a base, it should be greater than 7. Here's another technique. If pH is equal to negative log of H+, then logically POH is equal to negative log of OH minus. So if we were to find the POH, it's the same as finding the pH. We use the same technique. How do we get that into pH then? pH, we'll simply take 14 and subtract the pH, POH. And so let's try this, all right? We know so let's try this. What we're going to do is we're going to find the POH. We're going to say POH, it should look like an O, is equal to negative log of the OH minus. And then we'll subtract that from 14. So we're simply going to say negative log. Let's remember, it should be one negative. Negative log. I'm having a hard time this morning, ladies and gentlemen. Negative log. Here we go. Now remember, our OH minus in this situation is 6 times 10 to the negative 3rd. So let's plug that in. 6 times 10 to the negative 3rd. Make sure we enter it right. 6 times 10 to the negative 3rd. Here we go. This is our POH, 2.22. Let's subtract that from 14 to get this into pH and see if we got the same answer. We got 11.78 when we did it the other way. Let's see what happens here. So we'll take 14, we'll subtract from this 2.22. I got a feeling it's going to look very familiar. 11.78. Either one of these techniques work. All right, take it for a spin.